This is 2014 Paper 1 Question 3a. It's one of the first group of induction questions, which is the series group. And this question kind of behaves like an unofficial proof because every time you do it, it's the exact same. So we'll start with the first step of proof by induction, which is always the same. Prove that it's true for n equals to 1. So 1 on the left here, as in 1 on the left means the first term, and the first term on the left hand side is 1. On the right hand side it's a formula, and we need to make n 1, so it becomes 1 times 1 plus 1 over 2. So this is 1 times 2 over 2, which is 1 times 2 is 2, and 2 divided by 2 is 1. So it is true for n equals 1. So the second one is the assumption, which is to assume it's true for n equals k. So we have 1 plus 2 plus 3, and then it is at the moment plus n, but we're going to make that a k, and it equals n times n plus 1, which will become k times k plus 1 all over 2. So that's our assumption. Step 3 then is to prove that it's true for the next step, which is k plus 1 based on the assumption. So first of all, what does the k plus 1 term look like? So it's 1 plus 2 plus 3 plus, we're going to leave the k there and then just put in the next term, which is k plus 1. And then here we replace the k's with k plus 1's. So when this k gets replaced with k plus 1, we have a k plus 1 here and then another 1. So it becomes k plus 2. And that's over 2. Okay, so we're going to use the assumption now. So we're going to take this bit, which is the same as the bit in the assumption, and we're going to let it equal this. So obviously this yoke isn't there, that was just there to explain. So we're going to let it equal k times k plus 1 all over 2. And that's based on the assumption, which you always have to do in step 3. Alright, and then we still have this plus k plus 1, and we need to show that that's equal to this thing, which is k plus 1 times k plus 2 all over 2. So we're going to work on this left hand side and hopefully make it equal the right hand side. So the first thing I'm going to do is take out the k plus 1. So there's a k plus 1 in this term and there's a k plus 1 in this term, so I'm going to take out the k plus 1. So in this, when I remove or divide out the k plus 1, I'm left with k plus 2. And in this term, when I divide out k plus 1, I'm left with 1. Alright, so I'm going to do a common denominator on this bracket. So leave the k plus 1 alone. And then this bracket has a common denominator of 2. 2 into 2 goes once. 1 times k is k. And 1 into 2 goes twice. 2 times the 1 here is 2. Okay, so what I'm trying to prove that it's equal to is this thing here. K plus 1, k plus 2 over 2. So if I put this over 1 as well, I just have fraction multiplication, so it's top by top, bottom by bottom. So I'm going to do k plus 1 times k plus 2 over 2, which is exactly what I have up here in the yellow box. So that equals the right hand side. So that's what I was attempting to do. So then you put in your final step, which is, I suppose, technically step 4 of your proof by induction, which is that we have shown that the proposition is true for n equal to 1. If the proposition is true for n equal to k, then it is true for n equal to k plus 1. So we proved k plus 1 using the assumption, so that's what that second line means. And therefore, by induction, it is true for all n is an element of n. natural numbers.